Alright, so the last video of my sort of very brief intro to R series that I used to start my graduate statistics course is going to be about functions. So functions are sort of pre-written code that help you run analyses. So if you think about R so far, what I've really shown you is some functions, but also that it'll do math. Now, least squares is not difficult math. That's the math that makes most linear models, including ANOVA, run, but it is still like some math that would take you a while to code. So instead of you having to write it, somebody else has already written that for you, so you can use those functions to complete your analysis in a simpler way. So you don't have to tell it to sum all of the data pieces and then divide by n. You can just say, give me the mean. So ways to get help on functions, as helpful as things can be, is to do question mark and then the thing you're interested in learning more about. So let's make this a little bigger over here. So let's try question mark LM for linear models. So linear models run regressions, ANOVAs, that sort of stuff. And so it tells you everything that's involved in a linear model. Let me blow this up here. So it tells you what the formula is, it tells you what each piece of that is, gives you some more details. So LM is a really well documented one. It goes on and on and on and on and on. And then it gives you some examples. Now, if you're brand new at this is probably going to be like gibberish the first couple of times you look at it. And I think as you look at more of them, they start to make more sense. My biggest, not problem, but my biggest thing that I struggled with was what out of all these things, including what the hell are these ... did I have to have? So what were the things that were required to for me to run this? And so the easiest thing to do is just try it. If it runs, great. If it gave you the answer you're expecting, double great. If it doesn't run, you're missing something, and it will warn you that you're missing something. And so here's an example of an NA action. NA action is one of the codes for what do you do with missing values, so it's actually part of the function. And it has a subset function as well. And then the formula is like what math do you want to run, what's the data set. So there's some options here. And so let me close this bad boy. But that's how I can get help on it. There are other couple of things you can do to look at functions. Is to do help function. That works the same as a little question mark, but also args. I like args because I can look at like what are my options without having to flip through all the help pieces. So args tells me what all the arguments are, and once you've done these for a while, you'll be like, oh, NA action. Why do I always think it's NA omit? It's NA action. But then the help function will often tell you what the options are. So NA if actions, blah, 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 and it tells you maybe what some of the different, it's going to be a true or a false, but sometimes there are like, use this one or use this one, and it'll tell you what the options are. All right, so what do I mean by arguments? Because that's probably a new term too. So functions have a couple of parts. The name of the function, like mean, LM, sequence was a function we did, repeat was a function, concatenate, variance. So they have a name. And then the arguments are all the things that are required within the parentheses to make it run. So arguments are the things that you have to type in the parentheses for it to do its thing, its math. So you can get help on functions by doing an example of the function. And that will give you the example that's listed in the documentation. I don't know how helpful those are sometimes if you've never seen one before, so I always Google, and Quick R, which is a link that I've included at the beginning, is actually really great for examples of simple things, plots, ANOVAs. But there are tons of examples on the internet, so Google it first. They all usually have a little more description than the example function included in the documentation. So let's write a function. So if it doesn't do what you want it to do, you can actually write your own little functions. And we're going to write one called pizza, because I like calling things pizza. And what you do is you tell it what you want the pizza function to do. So first thing we're going to do is we're going to give it a name, which is going to be pizza. Okay. So that's the name of the function. I'm going to tell it I want it to be a function. Make this bigger so you can see it. And then I'm going to put how many things do I want them to, them being users, to list for me. And I just want one variable. So I could call this x or I could call it cheese. You just can't put in numbers. And then what do I want the function to do? So I've got brackets to say this is where the function starts and ends. And I want to take x because I used x here, and I want to square it. So you could do x times x if you wanted. Or in the notes, what I did was a little caret symbol, and then the 2, and that just means raise it to the power of 2. Okay. So that function will take whatever number that people put in the parentheses and square it. So let me highlight all of that and run it. And once you do that, over here in the environment window, you actually get a new piece that says function pizza. And it shows you the little function that you wrote if you click on it. You can also do help for pizza. Not help. You could do args pizza. So it'll create some of these things on the fly, but it doesn't have a whole lot of documentation because I didn't add it in. Okay. And so I could have called that x anything. So it doesn't have to be x. It could be cheese. Oops. But whatever you call it here also needs to go here. Okay. Oops, I apparently already have a variable named cheese. Let's call it pep for pepperoni. To continue this silly example. Oops, I'm going to highlight all 3 lines and run that. Okay. And so it doesn't like what I did for a reason that I can't. Oh, I've got double parentheses. There we go. That's the problem. It didn't like that for some reason. There it goes. So now I have a function named pizza whose argument is pepperoni. But it doesn't really matter what that variable is as long as it is consistent. So don't spell it one way here and another way here. So how would I use that? Well, I could type pizza and then put a number in. So I did pizza of 4. Well, 4 times 4 is 16. So it gave it back to me. It didn't even need to tell it that this is pepperoni. I just could plug in a number. You could also do this. And it would know what that meant. But that's too much typing, so I can just enter 4. Now it does have to be numeric or you will get an error message. So if I did pizza of t, it would say pep squared is non-numeric. And so sometimes you'll get these arguments, you're like, what the heck is going on? Well, that's because that's what they called the name of the variable. But what they're really saying is t, which you tried to fill in for pep here, is not numeric. So I cannot square a character value. It doesn't like that. Okay. So you've written your first function. Awesome. Go you. Okay. So the formal argument is where you define the function. The actual use of the function or the actual argument is where you use the function. Okay. And you'll see the difference here is I've got a definition and then here I'm just using it. So 2. There are a bunch of functions that actually want to take out some of these. Save this. This is where I started with my sim package, and so we were talking about Levon a lot. Recode is in the car package, so the rest of these are base R. I'm going to go over just a couple of them that I have found useful, and then we'll use them again when we get to data screening. Okay, so the table function is really awesome because it gives you a frequency table. So frequency tables, remember, have a list of all the values and then how frequent they are. And so let's try that. Let me clear everything out here and reload the air quality data set. Okay. And look at the first couple of columns. There we go. Okay, so now I can look at what the columns are over here. So some functions. The first one's table. Table will give you a frequency table of everything going on. So let's say I want a frequency table of the month. Right, so I can use air quality, and I'm going to take just the month column. So remember the $sign gives me just one column. And it will tell me that I look like I've been using 5, 6, 7, 8, and 9, which I should know is May, June, July, August, September, and then how many days there were in that month. Not too surprising. I could take a frequency table of the ozone column. That's going to be a much bigger frequency table. So it doesn't really do grouped frequency tables. It just gives you exactly how many of each of the values you have. So this works much better on character columns and on columns with only very few values. Okay, so it's a frequency table. If you don't want to do frequency table, instead you want to do a histogram, because histograms make more sense with continuous data. The option is hist. There is a histogram function, but it is in a, I can't remember what package it's in, but it's in one of those packages that you use a lot, so you think you can get away with it, but the base R version is hist. Okay, so let's do hist, and let's try that air quality ozone one again. Okay. If you get this error message, figure margins too large, what that means is that your plot's area, little piece over here, is not big enough for it to make the plot for you. And that's happening because I have my text blown up pretty large so you can read it well in the video. If I make it bigger, there it appears. That was a new one that happened to me recently. I'm normally working with a much smaller screen when I actually do these analyses. Alright, so once you actually have a plot, here's a quick thing on plots. You can hit export, you can save them as images or PDFs, or copy them to clipboard. For example, if you have homework for Dr. Buchanan's class, you can cut and paste them into your Word docs. Okay. Or you can save them, clear them out, that sort of thing. Alright, let me go back. So hist will give you a histogram, which has the values along the bottom and the frequencies up the side. The summary function is probably one of my favorite functions because it's so smart. I don't know who wrote this function, but it must be pretty complex underneath it, because what summary does is it takes the type of data that you give it, vectors, lists, data frames, matrices, and summarizes it based on the type that it got. So if you give it a summary, ask it to give you a summary of a data set, it gives you each column individually, looks at the type of column that it has, and then gives you an appropriate summary. So for example, if you have a factor column, it gives you a frequency table, which is so awesome because I can't tell you how many freshmen have given me the average of a gender column, which is totally not appropriate. You should do a frequency table for character columns, or factor columns. Anyway, so it gives you the min, max, quartiles, and the mean. And then if you give it ask it to give you a summary of a list, it actually gives you the sort of brief overview of the analysis. So I love the summary function, it's great. So let's look at what it does. So I can take a summary of one column at a time, or actually can do a summary of an entire data frame. That's much faster. And so what it did was it gave me the min, the max, the number of NAs, super helpful. That tells me how many NAs by column I have. First quartile, third quartile, and then the second quartile, which is the median, and the mean. The only thing that would make the summary function better in life would be the standard deviation. So we'll talk about how to get that in a second. But summary is a really quick and dirty way to look at what's going on in your data. It's very similar to descriptives in SPSS. Okay, so here's an example of the summary function, and here's an example of a summary function on a regression analysis. So it gives you very different things depending on the type of data that you input into it. So basic descriptives, so COVE is a covariance table, CORE is a correlation table, you got mean for average, VAR for variance, and SD for standard deviation. So you can do those one at a time, but you do need to do them for mean, variance, and standard deviation one column at a time. Now correlation, this is the next slide, one of the things that is problematic, sorry, just kidding, with things like correlation is that they have very different NA issues. So let's look at just the mean. So let's take the mean of that ozone column. I actually already have it here as 4213. It's this part I have highlighted. Oops, here. But if I was trying to just do the mean of that one column, actually what it gives me is NA. It's like, the mean doesn't work with NAs. So what can I do to fix that? Well, I could first omit all the NAs, but I could also look at the help for mean, and it has an NA function. So na.rm, so NA remove, is the option for the mean to remove NAs. So what I do is come up here where I have mean, hit comma, na.rm, so it gives me that option, and the answer is true. I do not know why in most of these base functions the remove NAs option is always set to false. The default is false. Not sure, but it is a thing. So I want to turn that on. And now that I've told it to just remove the NAs as you go, I get 4213, which is how the summary function calculated it as well. All right. Okay, so we did this one. Na.rm is true, so na.rm is remove NAs. I could also do the subsetting, which is one of the previous videos. Complete.cases or NA omit. So if I pull up the help file for variance, covariance, and correlation, because they're all very similar to each other, you can see that some of them have NA functions and some of them don't. So let's do that by typing !core. Nope, just core. Correlation, variance, and covariance matrices. It's like blah, blah, blah. I explained it to you. So na.rm, we just went over that one. These two don't appear to have NA options. Well, that's because they're called something else. Use. So use everything. This is one of the only ones that, to me, it's fairly well spelled out. And this one is giving a method with missing values. This must be either everything, all obs, complete obs, NA or complete, or pairwise complete obs. And pairwise complete obs is pairwise removal in SPSS. Complete.obs is list-wise removal, taking them all out. And so you would say use equals pairwise or complete, pairwise.complete.obs. So when dealing with functions, understanding what their NA removal options are is always helpful. Okay. And so here's an example of a correlation table and the use function that you would use instead of na.rm. Last but not least, I want to talk about scaling data because the first chapter of the field covers z-scores, so I thought I'd tell you how to create z-scores from your data. And that option is scale. What scale does is it z-scores the data. Pretty clear. If you're instead wanting a mean center of your data, but not z, so just subtracting the mean from everything, which is what a super useful function for moderation, what you'd say is scale equals false. Okay, scale equals true is the default. So let's do that real quick. So let me try my ozone data again. So I want to do scale, air quality, $ozone. So I want to scale that data, and what it does is it shows me actually down here what it scaled it with. So that's the mean and the standard deviation. And then it shows me all the scaled pieces, which is not what you wanted, right? You want to save that as something else. So I can say zozone for Z ozone equals scale the ozone column. And that would save the column so you could then do stuff with it. So you could check and make sure, that it did what you wanted by taking the mean. So if I take the mean of that column, it should be 0. Okay, and it gave me an NA because, of course, so na.rm equals true. Okay. So the mean is this crazy number. What the heck is this crazy number? Well, that's scientific notation. If you were like me and you're like, oh god, scientific notation, that was like junior year chemistry, you can turn that off. So options, scipen equals, and this is going to be confusing, 999. that will turn off scientific notation. But you'll have to do it every single time you open R. Okay, so let me rerun that. And then now I have the real number. So the mean is 0, which is correct, or it's very, very close to 0. And what if I want the standard deviation? Well, it's SD for standard deviation, ozone. Let's see what it gives us. It gives us NA. I can't remember what standard deviations NA options are, so I'm going to do a question mark, and it's the same, NA.rm. Oops. Don't do double NA, it'll get mad. And so the standard deviation is 1, because the standard deviation of z-scores is 1, always, and the mean is 0. So, or very close to those numbers when you calculate. And so that's how you would calculate means of standard deviations and create z-scored columns. Remember, you have to save them. So if you get output, you're not saving it. Okay, if you want to save it, make sure, or if you want to use it again, make sure you save it. And then don't forget, you could actually take this column, this new column of data, and combine it with your other data. So I could tack it on to the air quality data set by using the cbind or column bind function that we talked about in one of the previous videos. So all that taken together is some basic functions, and especially understanding the idea of missing data within functions, and then histograms, frequency tables, and z-scores.